Namaste everyone. Today we are going to learn about the chapter motion, which we are learning from the past 3 years. So I don't think so we will take a lot of time to understand this lesson. So let's start. At a glance, when an object moves with respect to the surrounding and time, that is called as motion. When the object is at a place without moving with respect to the time and surroundings, then it is at rest.
Let's discuss some examples of motion. The average speed of a bullet train is 320 kilometers per hour. As I said you before, the motion is which when an object's movement is done with respect to the time and surrounding. As you can see, the bullet train is traveling with respect to the time and surrounding. It's changing its stations, its time. It's traveling 320 kilometers per hour. As well as with the car, the car is moving with respect to the surroundings and time, as well as the this ball which is moving to the downward slope. uh, these are the examples of motion. Distance and displacement. Distance, the length covered by an object from one place to other, is called as distance. For example, you take 2 points A and B. An object is moving from the point A to B. The length taken, or the length covered by the object, is called as distance. The displacement. The shortest distance covered by an object from a starting point to an end point is called as displacement. For example, take 3 points A, B, and C. When you go you want to travel to C, then the person at A travels to B and then C. To calculate the distance, you will do A plus B and B plus C, but the displacement is A to C. Speed and velocity. Speed, the distance covered by a particular object with a given time, is called as speed. The speed is compared or used to compare between two objects, and it is also used in other comparisons. Velocity. The meaning of velocity of an object can be defined as the rate of change of the object's position with respect to a frame reference and time. I I do hope that you didn't understood. Let me say a simple meaning of that. The velocity simply means that the speed of an object given with a direction is simply called as velocity. Example of velocity. As you can see, the car is traveling 30 miles per hour east. As you can see here, that the car is noted with the speed and the direction. With the second car, the car is traveling 60 miles per hour northwest. Even here, the speed and the direction of the car is given. As well as the third car, the speed and the direction are mentioned. So this is the velocity. Average speed. Average speed is the ratio of the total distance traveled to the total time taken. Average speed's formula is equals to A average speed is equals to total distance traveled by the total time taken. Let's take an example. A car is traveling 60 kilometers per hour, 60 kilometers within 6 minutes. So the ratio 60 is to 6, which is equals to 60 by 6. uh, 660 divided by 6 is equals to 10. So the average speed of the car is 10 kilometers per hour. Average velocity. Average velocity is the ratio of total displacement to the total time taken. Average velocity is equals to total displacement by total time. Average velocity is also the mean of initial velocity, which is denoted by u, and final velocity, which is denoted by v. Average velocity is equals to initial velocity plus final velocity by 2, or u plus v by 2. This is a formula of the average velocity of any object moving. Scalar and vector quantities. Scalar quantity. The quantity which is related with the magnitude of the object is called as scalar quantity. Vector quantity. The quantity which is related with both magnitude and direction of the object is called as vector quantity. Let's know the simple meaning of this. The scalar quantity, the scalar quantities uh, is given with only the magnitude, which means the speed it is traveling, whereas the vector quantity is given with the speed as well as the direction it is traveling. So hence we knew the meaning of scalar and vector quantity. Let's know the meaning of uniform and non-uniform motion at a glance, because we are learning these from the past 3 years, so I don't think so that we need a brief explanation about these two motions. Uniform motion. When a body is moving equal distances in equal intervals of time, then the body is said to be in uniform motion. When a body is moving with irregular distances in irregular time intervals, then the body is said to be in non-uniform motion. Let us take an example of these two motions. The movement of clock's hand and movement of pendulum is the example of uniform motion. As you can see, the clock's hand which move in uniform motion round the clock, as well as the pendulum bob. Whereas when you see the basketball and the asteroid, you see that they are totally different and opposite to uniform motion, so they are non-uniform motion. Acceleration is the rate of change of the velocity, whereas deceleration, when the velocity decreases, then it is called as deceleration. When the velocity of an object increases, it is termed as acceleration. When the velocity of the object decreases, then it is termed as deceleration, as these both terms related to velocity. Examples of acceleration. Four different ways to accelerate a car. Car A, constant direction with increasing speed. Car B, constant direction with decreasing speed. Car C, changing direction with constant speed. And car D, changing direction with change in speed. I think so that deceleration shouldn't need an example, because it is it is very easy to understand, and it is the decrease of velocity. Distance time graph. Motion can be represented on the distance time graph. In the graph, distance is taken on the y-axis and time is taken on the x-axis. The distance time graph for uniform speed is a straight line. This is because in uniform speed, a body travels equal distances in equal intervals of time. So let's know what is this distance time graph. The distance time graph for uniform motion. The distance graph is in a straight line because there are equal intervals of time within equal distances. As you can see, the coordinates of the graph, that the x-axis and the y-axis are equal as the uniform motion. The distance time graph for non-uniform motion is non-linear. This is because in non-uniform speed, a body travels unequal distances in unequal intervals of time. Uh, to depict that, in this graph, they showed that the coordinates are different from each other. So this is a non-uniform. Let's know about another time graph called as velocity time graph. The area under a speed time graph represents the distance traveled. This is a velocity time graph of an object moving in a straight line due north. The displacement of this object is the area of the velocity time graph. So let us know what is this distance time graph, and let's solve some examples about this velocity time graph to understand it.
Example of velocity time graph. Velocity time graph for uniform acceleration. The coordinates are uniform as you can see, and they depict the graph. Constant velocity depicting in a velocity time graph. As you can see that constant velocity is constant throughout the whole distance it traveled and time it taken. Velocity time graph for non-uniform retardation. As you can see in the graph that the graph is gradually dropping, which states that it is depicting the retardation or deceleration of the velocity.